Hi Math 60. In this video we're going to talk about section 1.5 where we talk about addition of real numbers. So remember we talked about real numbers in section 1.4 and we talked about how real numbers are able to be located on a number line, right? And they consist of the rationals as well as the irrationals, which also includes the naturals and whole numbers and integers. So let's talk about how we can add two numbers, the sum of two numbers. The result of adding two or more numbers is called the sum of the numbers. One way you can think about this when we're talking about addition of real numbers, which include positives or negative numbers, you can think of this in terms of gains and losses to find the sums. For example, let's say you had $14 in your pocket, but then you lost a $10 bill. You would have had the following statement occur. You would have had $14, right, and then lost $10. Remember the word and means addition. We talked about that together in class. So this statement here that says you had 14 or you have $14, positive 14, you have that $14, and then you lost $10 is given by this statement right here. Right? And if you had 14 and then lost $10, you now have $4. Okay. In another situation, let's say you lost your wallet and it had $12 in it, and then you had to borrow $5 to get through the day, but you misplaced that $5 also. So the statement that you could use for this would be the following. You lost $12 when you lost your wallet, and then you lost $5. So how much money have you lost in total? You have lost $17. Okay, so this is how you can think of this in terms of gains and losses. To represent a gain, let's say you suppose you lost a $20 bill, but then you worked and you made $16. This would be represented by the following. You lost $20 and then what happened? You worked and gained 16, right? You gained 16. So this is a gain. So when you combine these two things together, a loss of 20 and a gain of 16 is an overall loss of $4, right? Or you would still be down $4 if you'd like to think of it like that. Instead of thinking about it in terms of gains and losses like this, we can actually use the number line like we were before in our previous section where we were locating real numbers on the number line. We can use the number line because really the addition of numbers is just going to come down to a counting situation. We just have to count in the correct direction. So let's let A and B represent real numbers. Remember, they can be rational, irrational, integers, whole numbers, rational numbers, natural numbers, it doesn't matter. To find A plus B, the sum of A and B, using the number line, what do we do? First, start at A. Okay, so that's saying start here at A, whatever it is. A could be positive or negative or 0 or whatever. Start at A, and then what do we do? If B is positive, if this number right here is positive, move B units to the right from A. If B is negative, move B units to the left from A. If B is 0, stay at A. The number where we finish on the number line after we move B units to the right or left, depending on if B is positive or negative respectively, that number where we end up will represent the sum of A and B. Let's try an example. So let's add the numbers 7 and -9, and let's use the number line. So just like our model, we start at the number 7, right? We start at A. That would be right here, this 7 number. So we start at 7. 7 is located 7 units to the right of 0. So that's over here. Okay. We start at 7, and then if we're going to add -9, this is the B, right? -9 is B. And since B is a negative number, we are moving in which direction? We move left, and we move left 9 units. So if we start at 7 and we move left 9 units, we just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. The number we end up at is the sum of 7 and -9. And where do we finish at? It's kind of hard to see where the labels are, but this is actually -2 right here because the labeling at the bottom is a little bit off. Okay, we have finished at -2. We can also count this out as we work because if this is 7, if we move left 9, this is going to be 7. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We've moved 9 units left and we've left ourselves at -2. We have a few properties that we should make use of when we're doing addition of real numbers. Some of these are very nice properties. For example, the first one is the identity property of addition. So let's let A be a real number, a variable, or an algebraic expression. Okay, for right now, we're considering A to be just numbers, but later on, when we're doing algebra with variables, it'll be nice that these same properties apply even if A is a variable or a complicated expression. So what happens with the identity property of addition is that if we take a and add 0 to it, we are still left with a. What this means, if you think of the number line, is if you start at the number a and want to add some number b. b is 0, which means do I move left or right at all to get to my result of the sum? I do not. I just stay at a. Okay, and that's why here I get a plus 0 is a. Alternatively, if I have 0 plus a, start at 0, I add a. That means I move a units in either the positive or negative direction, but whichever way I move, I'm going to be ending up at a. Right? Again, the idea is you're adding nothing, so you end up being just where you were before. And here are some examples. 7 plus 0 is 7. Here's an example with an algebraic expression or a variable being one of the terms. 0 plus 2x is 2x. Negative 3y plus 0 is negative 3y. Alternatively, because we have this way that 0 is being used in this identity property of addition, we can rewrite what's going on here to say the following. The inverse property of addition. The sum of a real number and what's called its additive inverse gives 0, the additive identity. So 0 is called the additive identity because when you add it to anything, you always get back the original thing, right? A plus 0 is a. Okay? You haven't added anything. What happens down here is when you add a and negative a, you will always get 0. These two numbers a and negative a are called additive inverses. And why are they called additive inverses? Because when you add them, you get 0. And again, negative a plus a is also 0. The reason this happens is because a and negative a are the same distance away from 0, but on opposite sides of 0 on the number line. So when you add them to each other, they cancel, right? And they give a 0. All right, let's talk about how we can add two numbers that have like signs. Either they're both positive or they are both negative. What we can do is add the absolute values of the numbers and then use the common sign for the sign of the result, for the sign of the sum. For example, if we were going to add negative 3 and negative 7, we add their absolute values. The absolute value of each of these two numbers is 3 and 7, because remember the absolute value just takes away that negative. So adding the absolute values is 3 plus 7, which is 10. And the sign that each of these two numbers had was negative, which means our answer should be negative also. Again, you can think of this using the number line. If you start at negative 3 on your number line, this says to do what? Add negative 7, so that means move 7 units to the left from negative 3, and that will put you where? At negative 10. The number line model is, like I said, a perfectly fine way to handle performing this addition. The reason we're generating a model like this, using these kinds of steps, thinking about the absolute values, is it will help us in the next section when we think about subtracting real numbers. How can we now add two numbers that have different signs? So this one gets a little bit trickier, but it's still a process that we can generalize to our next section also. What we want to do here is subtract the smaller absolute value from the larger absolute value number, and then use the sign of the number with the greater absolute value for the sign of the result. So for example, if we wanted to add negative 13 and 7, we subtract their absolute values. So the absolute value of negative 13 is 13, the absolute value of 7 is 7. We subtract those two numbers and get 6. 13 minus 7 is 6. Now, which of the two numbers, 13 or 7, had was larger? 13 is larger than 7, and it carried a negative, correct? Which means that our answer should have a negative on it, okay? What that really means is this number over here is more negative than this number is positive, right? So our overall answer should still have a negative number. This is kind of like when you were working in the previous couple slides ago, you lost $20, but then you worked and you made 16, you were still negative, right? It wasn't enough. This number right here wasn't enough to take over this negative number right here. Okay. Again, you can use the number line situation or example for this. You can start at negative 13 on the number line, and then you want to do what? Add 7, so we move 7 units to the right on the number line, which will place us at negative 6. But again, this kind of technique here, thinking of working with the absolute values, will be beneficial in section 1.6. Let's see how this process can be used to simplify algebraic expressions that have like terms. So for example, if we have negative 12x plus 5x, using the distributive property, we can think about this in terms of just adding the coefficients of the terms, correct? Remember from our section in 1.4, we thought about how to add like terms. We just add the coefficients from each of the terms before. except for now what we're doing is we're adding a negative number and a positive number. So using either the number line technique or the absolute value technique, you can see that negative 12 plus a positive 5 tells us to do what? Start at negative 12, add, move 5 to the right, which puts us at negative 7. So negative 12x plus 5x is negative 7x. All right. Let's see what we can do here with, these are just a couple more examples here. So if we have negative 12 and we want to add negative 5, construct a number line and start at negative 12, move 5 to the left. If we move 5 to the left, we're going to do what? Count over negative 13, negative 14, negative 15, negative 16, negative 17, and that's going to give us our answer of negative 17. Alternatively, if we wanted to add negative 10 and 14, we start out by starting at negative 10, and I want to move 14 units to the right. Now, thinking a little bit ahead, that should sort of intuitively tell us that our overall answer should be positive, because isn't this number here going to be enough positive to overtake that negative number? It will be, which is why our final answer is positive. And also, starting at negative 10 and moving 14 to the right will put us at 4 if you're using the number line technique. All right. So just a little final statement here with our adding real numbers. To add two real numbers with like signs, add their absolute values and use the common sign as the sign of the sum. To add two real numbers with different signs, subtract the smaller absolute value from the greater absolute value. Use the sign of the greater number as the sign of the sum. Or alternatively, as I said before, use the number line model. This is the end of 1.5. On to 1.6.